All right, let's now give this one a crack. So we need to draw this so that it's planar. Let's begin by just labeling everything. We'll call this A, we'll call this B, we'll call this one C, we'll call this one D. Now, what do you think we would have to move such that this now becomes planar? What am I going to have to move around? And you know what? I don't think I actually have to move any of the vertices. I'm going to leave all the vertices where they are. So I'm going to call this A, I'm going to call this D, I'm going to call this B. That's a funny looking B, and I'll call this C. So I'm leaving them where they are because I think I can just draw the edges in better places. So let's look here for a second. A needs to go to B, D, and C. All right, well, let's just draw that like this. Whoa, I totally missed that. Perfect. So A has gone to all of them. Let's now look at the next one. Let's look at B. B needs to go to A, C, D, and look, there's two. B goes to C that way, and it goes to C that way as well. All right, so that's going to make things a bit confusing, isn't it? Now, I can't cross through it, so what if I went C that way, and I went C that way? So it's looking a bit funky, but that's all right. B's already going to D, and he's already going to A, and B needs to go to D as well. So let me do this, like that. Okay, we keep on going. D needs to go to C, D needs to go to A, D needs to go to B. All right, so I just need to connect that there, and everything else already exists. It's already going to A, it's already going to B. What about C? C needs to go to D, it's already there. C needs to go to B, it's already there. C needs to go to B another way. So C needs to go to B two ways. So what if I did this? Whoa, like that. All right, that's that one done. C needs to go to A, that's already done. And C needs to go to B that way, and C is going to be that way already. I've already put that one in. Now, looking at that, I have gone around, I've double-checked everything. That's what it's going to look like. So a little bit of a funky-looking graph, but we have done it. All right, now let's label things. We have to figure out the edges. We have to figure out the faces. Sorry, we'll go vertices first, won't we? We'll go vertices, what are the edges, and what are the faces? Well, I've got 4 vertices. How many edges do I have? My goodness, I've got 1, 2, 3, 4, 5, 6, 7, 8. I have 8 edges. How many faces do I have? 1, 2, 3, 4, 5, and then the outside one is 6. So remember that outside one is 6. So now, if Euler's formula is correct, what should happen is I should be able to go 4 minus 8 plus 6 is equal to 2. 4 minus 8 is negative 4 plus 6 is 2. So that is correct. This works. Hooray. Euler's formula is verified here. That is correct. This must be, so a planar connected graph. So both of these, what we can say for both of them, therefore, both are connected planar graphs. Perfect. Hopefully you found this helpful, and I'll see you later.